beautiful, beautiful documentary. I have to warn you, this is probably the first one of the year that's like doom and gloom, and we have more like that coming. There's kind of a lot of doom and gloom ASAPs coming up that are like depressing and scary, and we're all going to die because the world is dying and we're all doomed and we're all going to die. This one I think is my favorite of the gloomy ones because it's about the collapse of global fisheries, and they have like real scientists speaking, some of whom I know. They discuss like real modern research that's like recent numbers of like globally consolidated research data, which I think is very scientifically relevant. They have a lot of interesting details, like really beautiful visuals. I'm into fish, and so there's like spectacular fish. The computer graphics are all like kind of eye-catching and thoughtful and useful. They're all about the data. It's like a really good, modern, tight documentary. It's excellent. It's called End of the Line. It won a bunch of awards. I should warn you that if you have like a really, really sensitive stomach, it does show commercial fishing boats. And you may know that commercial fishing boats aren't always sensitive and lovey-dovey with the fish. So if you weren't ready for that, I gotta give you a heads up that it shows commercial fishing boats doing what commercial fishing boats do, which is sometimes hard to watch. Are there any questions for me? Tomorrow you have a lab prep, which includes bringing 2 cups of soil. Aaron, are you using a cell phone right now? Bro. Imagine how much it would hurt if it hit you in the eye. Take care of that eye. It's a lovely eye. Two cups of soil, detailed material list, very detailed procedures, plan ahead for the data collection. Are there any questions about tomorrow's soil lab? Thursday's soil lab. Cool shirt. I love Pacific Pickle Works. They give me very good pickles. Have I told you this already?
Yeah.
Yes. Did we talk about this every time you have a shirt? Do you have a shirt on?
Yeah, I wore it once before and you said it.
I'm sure we'll do it again next time. See you there. Have I already invited you to participate in the transition of the aquaponics project,
Yes.
the first meeting of which is tomorrow at lunch? And we've already discussed your grades, and so our goal today is to finish modern agriculture in assignment 4.1, and then we'll start talking about soils in 4.2. You'll need to go through those assignments. Please take them out now. Amigo. Time to go water shopping.
Water shopping?
Yep.
Yeah.
It means carry this light box down to the Mat Academy and make it heavy.
Favorite part of the day. Everyone looks at me like I'm just crazy. And all the teachers there give me so much shit for it.
I mean, everyone has always looked at you like
Do you have a towel so I don't get rust?
Where did we leave off yesterday? Did we talk about the Liebig distinction versus people who treat soil as an ecosystem? Damn. Oh. There was this guy named Liebig who had a very simple but very influential observation. He said that the growth of a plant must always be limited by some nutrient that they need more of. And if you can figure out what that is, you can add that nutrient to make the plant grow more. That's called Liebig's law. That a plant can always be made to grow more by giving it whatever it needs at that moment. That's all I gotta tell you about Liebig right now, but just so that we can look ahead a little bit. Liebig was the beginning of a shift in agriculture, where people went from trying to keep a healthy soil to people rushing to always supplement soil with chemicals. The practice of using synthetic fertilizers came from people using Liebig's law to manage their farms. And I should point out that it's no way for you to grow a human either. Imagine, homegirl is sick, she comes to the doctor, we know there's something wrong with her diet, and so I say, here, take iron pills, I'll see you in 2 weeks. And she shows up in 2 weeks and I go, okay, now it seems like you need some vitamin D, have some vitamin D pills, and then come back in 2 weeks. And then she comes back and now she needs calcium. So I say, here, have some calcium pills, I'll see you in 2 weeks. And I have to always be keeping up with whatever is missing by adding that. But I think everybody knows that there is a simpler and probably more successful way for me to help her with her diet, which is just, here's how you eat a balanced diet, and that should have everything you need to be a human. Do we agree with that? The problem with Liebig's law is that conditions are always changing, so you always need to add some fertilizer. This is a distinction that I want you to add to your number 33. Please look up. You can always figure out what the soil needs. It's called demand-based agriculture. Like now we gotta add more nitrogen, now we gotta add more phosphorus, now we gotta add more potassium, now we gotta add more calcium, now we gotta add more whatever. That's study goal number 7. The term for this is demand-based agriculture, where you're always using chemicals to fill in something. And by the way, this is common. This is the majority of the world's agricultural food supply. This is like a big thing. This is the way most food production works globally, and I think it's a bad idea. Use a bunch of scientists and a bunch of chemistry and a bunch of bottles to always add whatever is needed at that moment. This is a very synthetic way to think about plant growth. The soil is like a dead, empty sponge that you add supplements to. And I don't know if you like know any people who eat a supplement diet, but to me that always seems like, I don't know, it's just kind of too sketchy. Trying to survive on a whole bunch of pills, that's just, I don't know. Yeah.
What does it say to the right of Liebig's law?
It says FERT for fertilizers.
Even more to the right.
This is as opposed to what I consider to be a more sustainable alternative, which is ecological soil management. Treating your soil as a food web. That's like the rounded diet metaphor. This way of farming, please look up, is what we call resource-based in number 7. Where instead of trying to figure out what the soil needs more of, you just try to figure out what else you can add to that balanced profile. We don't really have any feather meal in there, let's try some of that. Most of the good farmers that I know, they don't use soil labs and chemicals from a bottle. Most of the good farmers that I know, they use what's called ecological soil management, which is key term you must have, soil food web. Treating the soil as an ecosystem, it's a food web. Look up here, please. You might remember at the beginning of Unit 2, or maybe it was Unit 3, we talked about food webs and food chains. And we talked about how, like, the trophic transfer is like energy storage from the level below that gets digested by the level above, and they spend 90% of that energy, and then they pass on energy. Remember we talked about this? And then all of that material gets looped back down to the producers through the action of what? Anybody remember? The decomposers. They're like recycling plant that turns all of the stuff that was alive into the next round of living things. This all sound familiar to you? There's a new term that I need you to add in number 6 or number 7. You can put it number 6, I think. It is this. Please look up. Humus. Don't confuse it for hummus. Hummus is a delicious Mediterranean dip made from ground garbanzo beans, tahini, lemon juice, sometimes garlic, sometimes olive oil, usually salt. So tasty. By the way, if you ever get into cooking, the secret to good hummus, I just found out, is to mix it a whole lot. Some crazy, amazing chemistry. Yes?
Also, if you let the chickpeas sit for like a few more hours, makes them better.
I'll buy that. Someone told me like 45 minutes of mixing. Like when you're too tired, get somebody else to do the mixing. Yeah?
Number 6.
Yeah, number 6. But I don't want to talk about hummus anymore. It's just making me hungry. Humus is organic material decomposing in soil. If you go to a modern industrial farm, the soil is light, thin, dense, and it's basically, it looks like sand. Like if you ever get like commercial lettuce, you'll often notice there's like sand in it. Because commercial farming does not do this soil food web stuff. Commercial farming just figures out what's needed and adds another bottle of demand-based fertilizer on a schedule thing. It's the way they grow all that indoor marijuana with like the spongy things and they add all the hydroponic stuff. That's exactly the Liebig concept. But the organic farmers, they do something very different. They treat the soil as an ecosystem, which relies on humic content, decomposing organic material. And they're always adding more stuff to decompose in the soil so you can build that food web in the soil. All those decomposers, all those bugs eating the decomposers and the bugs eating the other bugs and the bugs that eat that, they leave so many little bits of chemical chump change in the soil that plants grow better and they're tastier because there's just so much recycling and nutrient chaos in that ecologically active soil. He's good? Difference in soil management? Liebig and demand-based 6 and 7 versus soil as an ecosystem, humic content, the food web thing. Done? It isn't always modern agriculture. There have been old types of agriculture that worked really well. There are 2 traditional terms in number 8 you have to know. Anybody know the other way of describing bush fallow? The more common the more common description is one that's just more plain common English. Anybody know? Cyclical slash and burn. You cut down the forest and you burn it. Why do you have to burn the forest? Why do they burn it after they slash it? Where are all the nutrients in the tropical rainforest? In the soil? In what?
Plant.
In the biomass. So you cut it down and then why do you burn it?
Put it into the soil.
Because it distributes throughout the ecosystem.
That's right. To make all the nutrients available for growth again in that soil. To redistribute cycle everything back down in the soil. Bush fallow. Back in the day when people had low densities in the tropics, this was a perfectly sustainable way to make a living. Yanomamo Indians in Venezuela and Brazil have been doing cyclical slash and burn for unknowable centuries. And the forest is healthy and they have very successful agriculture because, you know, there's like one Yanomamo for every 20 square miles of forest. So as a group, they like slash and burn, and when that soil's no good, they go someplace else and find another flat spot, slash and burn, and then by the time they come back, the forest is grown back. So there's a few people making little patches. That's totally doable in small densities. Everybody got that? We can't do slash and burn in large scale. That's what's wrong with the tropics now. We grow a whole bunch of grain for animal feed in Brazil, but now we're slash and burning, you know, square miles at a time. And that doesn't have a chance to recover before we've moved on to slash and burn more stuff. Does that make sense? Small scale worked great, large scale not doable in the tropics anymore. The other term is milpa, which yes is the same as the street right over here. Because milpa is a Mexican Spanish word, and this was Mexico before it was California. And the street is named for the agriculture method. Anybody know what agricultural method I'm talking about? Does anybody know what milpa means in Spanish? Or milpita? Has anybody driven under the 101 at Milpas? You might, like if you ever go from the high school to the Habit, what are the lamp posts shaped like? That's right. Milpa is a corn plant, corn stalk. It might be a corn husk. I don't know. Something to do with corn. And milpa agriculture is the way that Mexicans grew corn for hundreds and hundreds of years, which was in seasonal wetlands. Remember that a wetland is dry part of the year and wet the rest of the year. That's why it's called a wetland, because sometimes it's dry land and sometimes it's wetland. So watch me. Wetland floods when all the water has accumulated, like the end of winter here. When there's like water pouring out of the mountains because the rainy season is finishing up, you get deep water in all your wetlands, right? That means you've brought in a whole bunch of sediment that has a lot of like sand, which is not the big deal, and it has a bunch of nutrients from organic material decomposing, right? Everybody got that? All that nutrient cycling in wetlands that we've talked about before, yes? And as the water recedes, you plant your corn. And water recedes, and then you plant more corn, and water recedes, and then you plant more corn. So as the water level is going closer to sea level, you keep planting in about an inch of water. Everybody got that? Corn seeds won't sprout underwater, they're drowning. But as soon as the water level reaches the seeds, they'll sprout. So you've got tall corn, shorter corn, baby corn, sprouting corn, water that you're putting corn seeds in, right? And as that water level keeps reaching sea level, the taller corn keeps reaching down to chase the water, and the corn keeps growing in these nutrient-rich wetland soils. When the corn plant can't reach water anymore, it starts to dry out. You harvest the corn and you kick it over, and 2 weeks later, you harvest this corn and you kick it over, and 2 weeks later, you harvest this corn, and eventually you reach sea level, and you wait for that stuff to dry out, and then you harvest your corn and you're done for the year. All that knocked over corn, gets flushed away in the next wet season, decomposition uses it all up, you've refertilized the soil and you're ready to do it again. Seasonal wetland agriculture. Super successful. Again, we have too many people to do that in large scales, but Mexico was built, especially northwest Mexico, the part of Mexico that we're in now, was built on milpa agriculture. And almost every major wetland in Southern California was a Mexican settlement because of this. Like if you map Southern California's wetlands, you've mapped colonial Mexico. And number 9, I have to tell you, this is a big deal. Persistent misunderstanding. The Green Revolution is not right now when everybody buys Priuses and steel water bottles. This is not the Green Revolution right now. Like everybody wearing Patagonia and idolizing Yvon Chouinard and stuff. Like this is not the Green Revolution. The Green Revolution was the early 1970s. When global food production became much more productive. We got way more calories per acre. We may have tripled global food production in a period of about a decade. We'll come back to that. What is selective breeding? Yes?
You know when you like take the best plant or organism and breed it with another one to create like the best of the best?
Yes, you take the best and you breed it with the best to make better.
Yeah.
Yes?
You like take specific species that has the like phenotypes that you want and breed them to get more of that phenotype and get rid of the other.
Everything you said is right except species. You mean individuals of a
Yeah,
species.
individuals.
Yeah. So if I wanted to make a taller breed of human, I would find the tallest human and breed them to the other tallest human, and their babies would probably be taller than average. And if I do this for 1,000 generations, I'll probably have taller than average humans. Yes? This is how we make chihuahuas. You find the smallest little dog, and you leave it in the dark with the other smallest little dog, and pretty soon they'll have little babies that are probably smaller than average, and you find the smallest of them, and you breed them together, and you find the smallest of them. Everybody got that? And by the way, since we're speaking of dogs, anybody here know stuff about dogs and dog breeds and you like dogs? Are purebreds usually the smartest, healthiest dogs? Anybody know why? They're inbred, right? What happens when you're always selecting for the tallest one or the shortest one? You might overlook the dumbest one. Or you might have to choose one that's kind of tweaked and stupid. Because they've got the right characteristics, you take it anyway, right? Selective breeding gives you exactly what you want at the expense of other qualities. That's an important detail. So German Shepherds, they all get hip dysplasia. Anybody had this experience with a German Shepherd? Hip problems? Black Labs too, chocolate labs, hip problems. Anybody had a mutt that was much smarter than a purebred? This is the thing about dogs, it's real. Because when you're choosing for the characteristics that make the purebred, you have to sacrifice other ones like IQ or hip joint health.
There's like mad sponsors, like really adult people that were telling me to look at mad. And you're like, what are you doing? I'm like,
Why Jose?
I didn't know, I didn't mention your name, so I didn't talk to them. I just didn't want to explain.
I want to have you do this forever. This is awesome.
Wait, do you want this since it's cold?
No, thanks, buddy. I got another one. So students, how does genetic modification work? Which is not selective breeding. This is a one thing does not equal the other. How does genetic modification work? Yes?
You pull a gene out of a single gene, out of a single cell.
Were we talking about this yesterday?
Yeah.
Now, we've defined this. The Green Revolution was not genetic modification to make high yielding strains. It was selective breeding, old fashioned style. And your definition of green revolution must include a few words. That's why I took this long side trip. Green revolution, 1970s, tripled food production globally by selective breeding for high yield varieties. Thanks, Amin. Excellent work. High yield varieties. So instead of waiting 5 months for the wheat to grow, we could harvest after 3 months. Everybody here saw a movie from the 1980s about the food unit on the day I was absent, the first day of this unit. IR8, Indonesian rice number 8. That was a variety of rice that was selectively bred to create rice grains earlier in its life so you could get more rice harvest in one season. But like German Shepherds and English Bulldogs, when you get the characteristics you want, you're going to sacrifice some other ones. So unfortunately, those high yield crops, they're also kind of weak. They're spindly, they need extra pesticide, and they need extra fertilizer. That's something else you have to know. Green revolution, selective breeding, high yield crops, a lot of chemicals. They need fertilizer and they need pesticide. English Bulldogs can't survive in the wild. They need a human to give them food out of a can, you know? Those fugly cats that have no fur. You know they're not going to survive in the wild. They got exactly the qualities we want. They look, I don't know, perverted and like disgusting. I don't know, white people. But that whole like lack of fur, that's trendy these days. In exchange for the qualities you want, you lose some of the other qualities you need. So in the Green Revolution, we were able to really maximize output. We could get more crops of rice in a year. We could get wheat that would produce in 3 months instead of 5, so we could grow wheat in colder regions. If you have a shorter summer, now you can grow wheat because it only takes 3 months. Flip side is, those plants don't really grow on their own. Early agriculture was pretty much put it in the ground, go harvest later. Now, it's put it in the ground and this poor spindly thing needs a bottle of this and a bottle of that and we got to spray it with this to keep the bugs off. But then we get more production over time. See, the Green Revolution had like an interesting trade-off. Yes, we were able to feed more people. Yes, we solved the population crisis of the 1970s. We managed to quote-unquote feed the world, which was the title of the movie you saw on Monday when I was absent. But in exchange, we kind of got hooked on the agrochemical industry. And we had to irrigate the crap out of things too. We probably tripled fertilizer use, we probably tripled pesticide use, and we probably multiplied water use by 4 to 7 times over traditional varieties. Does anybody, can anybody tell me what the secret is to like Walmart and Amazon? They have very little markup. Have y'all noticed that? You can sometimes buy stuff on Amazon for way cheaper than you buy it at your local store. They only make like a penny per $10 item. How is that enough to run a business? They sell a lot of them, right? A little bit of profit on a huge volume is sometimes better than a lot of profit on a little volume. Ever understand that? Economy of scale? Yes? And sometimes your fixed costs, like running a website or putting stickers on stuff. Your fixed cost gets spread out over a lot of business. So sometimes it's more profitable to be really big. Everybody understand that economy of scale? When we could use all those chemicals and all that water to make food successfully, it also made sense, please look up, to take on the economy of scale in food production. It's called monoculture, where you might grow 30 miles of one crop. Anybody know why that's bad? One reason?
It just gets rid of diversity, it could lead to extinction of species.
Maybe, but these are crops that you, like, farming would have gotten rid of that habitat anyway.
Because it's like a single strain of something, it's really vulnerable to pests and like bugs.
Yeah, number one, can you imagine how excited a bug is when they see 30 acres of their favorite food? Or 30 miles of their favorite food? If you're like a potato beetle, and you fly over like a whole landscape of potatoes, oh, the pest problems are really, really difficult to fix. Monoculture can't be done without a lot of chemicals. Yeah?
Is that what happened with the bananas? Because like
Kind of.
didn't like one strain of a disease or something get into the traditional type of bananas and they had to genetically modify bananas?
Kinda. So globally we grow, almost all bananas are one species. More than half of our global banana crop is one strain of one species. Like Macintosh apple, like one strain of one species. I think it's called the giant blue or something. Anybody know what they call that banana? We've been growing that one banana all over the world for a really long time. It's super hardy. It's like really survives shipping. It's really sweet. It has like a really light skin. It resists bruising. It's perfect. And apparently there was a new disease a couple of years ago that we couldn't medicate against. There was like a fungus or something that grows on the bananas that we couldn't fix through chemistry. So we basically had to like reset the global banana production. And all banana farms in the world had to cut down the majority of bananas and replace them with another variety. And people talked about genetically modifying bananas, but I'm not aware of the majority of the crop being genetically modified. So, monoculture. Bad because of the pests. You can't keep the bugs away. Bad because of the banana issue. It's a giant gamble. You've put all your eggs in one basket, so to speak, for the farmer. And anybody know the third problem? What's going to happen to the soil if I grow bananas and then I grow bananas and then I grow bananas and then I grow bananas?
It pulls the same nutrients out every time, so you don't have like crop cycling to disturb the soil.
Exactly what he said. The soil profile is ruined for the one crop you're trying to grow because last year's crop took all the nutrients you need for this year's crop. Does that make sense? Different crops need different foods. So if I grow strawberries this year and corn next year, chances are I can grow strawberries the year after because the strawberry nutrients had a year to recover. But if I grow strawberries and strawberries and strawberries, after a while there's no nutrients left to grow strawberries, so I gotta add them. Everybody understand that? Yeah.
So you know, people who just, for instance, grow strawberries and strawberries and strawberries, would they like give them a spray like nutrient that gives back the nutrients that they get?
Yes. Yes. Basically, I want everybody to notice that this system that we have today, this is the majority of our global food supply. It's not like a couple of weirdos that are doing it wrong. This is your food. All these pieces are all tied together. Everybody's like, oh man, just stop using the pesticide. You can't. When a farmer is growing 30 acres of one crop, you can't stop. You stop for a day, the bugs move in from everywhere and they take off. Can you imagine the population growth of insects giving an unlimited food supply? You all know about like breeding like rats and like breeding like cockroaches and stuff. Imagine they have unlimited food. People are like, oh man, can't you just like use organic fertilizers? Not really, because we need to like pump in nutrients every day. You always need another one? The soil is all tapped out. And these are like high yielding varieties, so they're like running on turbo. You gotta feed them. Hippie farmers though, they do the opposite. As long as you have a healthy soil and you're growing different stuff all the time, the pests don't become resident, so you don't have the same pesticide challenge. Most hippie farmers don't need pesticide. Everybody always asks me, I talk to your parents about how our food production facility down here is organic. People are like, how do you deal with the bugs? Like, I don't deal with bugs. Like, we don't really have a lot of bugs. Like if the bugs come over that eat all the broccoli, we just take out all the broccoli and then those bugs are gone. And after a couple of years, we grow broccoli again. It's like kind of simple. We've got this like really interesting, super synthetic type of food production, but there's like a really simple alternative. Everybody in? Good? Finally, I want to talk about number 12, which is about GMOs, genetically modified organisms. Your book already said the potential for GMOs, right? So somebody who please does their homework, tell me number 12, potential advantages of GMOs, reasons that we are developing them. They could do amazing things like number 1,
Increase food production.
increase food production, they might yield more. Number 2,
It can form a symbiotic nitrogen fixing relationship.
yeah, so apparently there's that like potential for more nitrogen fixation naturally, yeah?
Crops that produce their own pesticides.
Yes, like this one, BT products. Please look up, you have to know this term. BT is Bacillus thuringiensis. It's a bacterium that's toxic to bugs. Bugs can't eat this bacteria. It's in the soil everywhere on the planet. If you've eaten dirt, you've eaten this bacteria. You've all eaten this bacteria. It's not toxic to you because you're not an insect. But please look up. We found the little gene that makes the toxin. It's called bacilliotoxin. And we spliced that gene into corn, into soybeans, into beets, into tons of products. They're called BT corn and BT soy and BT beets. Because it's the same old corn, soy, or beet, plus it makes the toxin of the bacterium in each of its cells. So bugs can't eat it. The bugs land on it, take a bite, and go, oh, that's nasty, and then they fly away. Okay, other interesting, exciting possibilities from GMOs, yes?
They can help tolerance to like drought and cold and heat.
That's right. So we might be able to grow food in places that we've had trouble growing it before. Anybody else? Yes?
You can develop new strains of crops with entirely new characteristics.
So for example, there's rice now that has like tremendous vitamin D or something. I don't know. But I want to talk about the exciting stuff your book did not talk about. What about number 1? Crops that grow medication. Like if kids don't like to take their something shot, what if we could give it to them in a nice, delicious strawberry? Or like, you'll never forget to take your birth control pill because this coffee has birth control in it. It's not just about how we dose people too. This might also make medicines cheaper. And you realize that a lot of medicines are very expensive to make in a laboratory, but if we could get the plants to grow that medicine, we could get huge volumes of medicine for cheaper maybe. Yeah?
Is that probably one of the main reasons that research is being slowed down, or like why that wouldn't happen?
No, I think overall the pharmaceutical companies see this as a potential profit source. As long as they're the ones that own that information, they can set the price to still be profitable. But for the pharmaceuticals, it is a way to either open up a new market, like coffee with birth control in it, or a way to make more profitable medicines because they spend less in the production. Number 2, what about animals that grow human body parts? Think of all the people who die before they can get an appropriate heart transplant or an appropriate kidney or whatever. What if we could just grow them in a pig for you? We could even get customized transplant.
Aren't they already kind of doing that with stem cells, or is that like under the branch of your head?
You know, I think we're right around the corner from doing this in large scales. I wouldn't be surprised if somebody had done it in small scale, like single. And I'm not really an expert on cutting edge biotech. I'm kind of afraid of biotech, so I don't really follow very much. Yeah.
Do you think that people would argue that that's like inhumane, like to do that to other animals, like to grow body parts?
I'm sure people would argue that, but we're already growing them to eat their belly fat. Right? Like, whether it's humane or not, we are already globally providing tons of bacon.
Bacon causes cancer.
So how about the touche and cure your cancer with bacon parts? So you can eat more bacon. Pigs lose, we win. Or number 3, what about microbes that make biofuel? Like bacteria that farts hydrogen gas, or like algae that makes its own biodiesel? Keep in mind, that would be using current carbon to run our fossil fuel systems. What if we could strip the power away from oil-producing regions and solve parts of the climate change issue by using current carbon, but still keep our fundamental gasoline systems? To me, that sounds pretty slick, so there's a lot of people in development of that. Anybody else heard anything cool about GMOs that I didn't mention in that list there? Cool. Number 13, the answer is really simple. Will there be enough water in the future to solve our food production problems? The answer is nope, absolutely not. That's your whole answer. So any questions on 4.1 before we move to 4.2? 4.2 vocab. There was only a few words. In assignment 4.2 then. Hooray for Steve Burr, rotational grazing in number 14. All right, Steve. I'm assuming you do your homework. For number 15, if you did your homework, you should have. And if you didn't, you should put a star because you should have done this one. Number 15, 1 star. All the good kids already know. Soil erosion, sediment deposition, on-site pollution from fertilizers and pesticides, off-site pollution from those things, habitat loss, desertification, aquifer degradation, salinization, the accumulation of other toxins, loss of biodiversity, and everybody should add one more. One big environmental impact of agriculture that your book didn't mention is eutrophication, excess nutrients in surface water. I'm guessing you all did that already, because you're all good kids who do your homework. Unlike period 3, oh my god. There are also a math class, but is that a thing? Like, does everybody know that the different math sections are very different, or is it just my imagination? Have you heard from other math teachers? What? You haven't heard that? Okay. I just noticed period 3 very different from this period 2 class. Can anybody tell me what caused the Dust Bowl? Yes?
They cleared land for farming, and then the good soil dried out because there wasn't any nutrients in it, and then they had large winds, and the dust just went everywhere.
Pretty close. Anybody want to add any details? Yes?
That dried at the same time.
Drought at the same time. Always windy, but they had broken up the soil into very fine, high tillage.
They
It's
lost-
easier to work in farming with very fluffy soil than it is with hard brick, hard pack. Yes?
Did anyone say intensive plowing?
The intensive plowing is what made it soft. Now we got all the parts. So intensive plowing, broke up the soil, heavy winds during a drought. One fun detail, it's very possible that that heavy plowing created the drought itself. It may not have been an act of God. Here's how, check it out. This is like a fascinating little thing in science, but if you're a science nerd, you're gonna love this. Condensation, precipitation, evaporation, condensation, precipitation. Everybody know the water song? Now please look up. Jet stream brings moisture, rains, evaporates, rains, evaporates, rains, evaporates, rains, evaporates. A water molecule in the jet stream might rain, hit a grassland, and evaporate, then rain and hit a grassland over and over. But hold on, hold on, hold on. Apparently cutting down all the grass and breaking up the soil changed the amount of times that water would evaporate and condense. So it's possible that farmers actually caused the drought themselves by removing the grass in the first place, because grass is water stored like a sponge. So it may not have been an act of God, it might have been the farmer's fault. Okay,
Wouldn't that just mean the water evaporates faster?
I think it has less water retention, so something about the amount of times. Yes. Or something about the timing of when it rained. I read a paper about this, I'm sure I got the details wrong. You should look into this kind of. Colton, will you please hit the red button for me?